Hello students, welcome back to Akshar IIT Foundation classes. I am your chemistry faculty S. Mohan. So students, here we were discussing 7th class. So we were discussing the chemical bonding chapter volume 2. In that term, we already completed 3 synopses. This is the 4th synopsis, right? So in the previous classes, what we did discuss? We discussed about the chemical bonding, what is with the chemical bonding and types of chemical bonds, and we discussed the ionic bond, Russell-Lewis theory. This all we discussed. And in the last class, we also discussed about the factors affecting the ionic bond. Yes, factors affecting the ionic bond. Factors what we discussed: size of the atom, ionization energy, charge on the cation or anion, and the inert gas configuration. This all we discussed, right? So today we are going to discuss mainly about the Fazan's rule. Okay, Fazan's rule. So students, this is a very important rule, that is the Fazan's rule. Okay, so if you see the Fazan's rule, it looks like the similar to the factors which affect the formation of ionic bond. Okay, ionic bond. What are the factors we discussed? It looks like the similar, but a little change is there. Okay, so what is the change? See students, here we discussed two types of bonds. One is called ionic bond. Second one is called covalent bond. What is ionic bond? The bond formed by the complete transfer of one or more electrons from one atom to another atom. Right? So when electron transfer from one atom to another atom completely, the atom which is losing the electrons, that attains a positive charge, which is called a cation. And an atom which is gaining the electron, that becomes negatively charged, that's called anion. Now the bond formed between two oppositely charged ions is called the ionic bond, right? This we discussed. What is covalent bond? We discussed covalent bond means the bond formed by the sharing of electrons is called a covalent bond, right? This we discussed. Now students, here if you see, for example, I'll take some two compounds. Okay, I'll take two compounds like sodium chloride. What's the formula? NaCl. What is this compound? Which compound it is? Is it ionic compound or covalent compound? Ionic compound, because sodium atomic number is what? 281, right? So 281. Chlorine electronic configuration this is, and chlorine electronic configuration is what? 287. So here what happens? This one electron is getting transferred, so this becomes 2,8 and this becomes 288. So here complete transfer of electron is taking place. This is the ionic bond, right? Now if I take another compound called KCl, potassium chloride. Okay, now what is this? Is it an ionic compound or covalent compound? Okay, now see, potassium atomic number is 19, so we write 2881 electronic configuration. Chlorine atomic number is 17, so we write it 287, right? So now what happens? This is unstable, this is unstable, so one electron get transferred here, so then it becomes 288, okay, and this becomes 288, okay. So both, so here also the transfer of electron is taking place, so the bond is formed, so this is also ionic bond. So sodium chloride is ionic bond and potassium chloride is ionic bond, right? Now if I ask you that, in these both, which is more ionic? If I ask, okay, in this which one is more ionic? You'll be confused. Yes, why? So this is also by the transfer of one electron is taking place. This also transfer of one electron is taking place. Both are ionic compounds. Then what is the question? Which is more ionic, which is less ionic, right? So here students, here no compound is completely ionic, means what? 100% ionic. And similarly, the covalent compounds also, no compound is completely covalent, means what? 100% covalent, right? So here in ionic bonds also there is a little amount of covalent nature is there, and in covalent compounds also there is little amount of ionic nature is there. Okay, so in some compounds, okay, if for example in these two, if you take sodium chloride and potassium chloride, sodium chloride is more ionic than the potassium chloride, more ionic than the potassium chloride. So more ionic than the potassium chloride means what? In this the covalent nature is very less. Here it is less ionic means what? In this covalent nature is little more than this one. Means what? Here also there is some covalent nature. Here there is also some covalent nature. Clear to you now? So in ionic compound also there is some covalent nature will be there. As well in covalent compounds also there is some ionic nature is there. Okay. So to explain this, Fazen proposed some rules. Okay. So that is called Fazen's rule. Clear? Very simple. Okay. So that is about the Fazen's rule. Now let us discuss about the Fazen's rule. Okay, how he explained. So before going to the Fazen's rule, we need to understand a little okay concept, a small concept. So that is polarization. Okay, what we discussed about the polarization. What is with the polarization? So see students here, generally, for example, what we say, atoms are generally spherical in shape. Okay, what do you say? Atoms are generally spherical in shape. Right. Now, for example, what I do, I will take the two atoms. Okay. So, one is small atom. This is a nucleus. Okay. And this is one orbit. Like, imagine one small atom I have taken. Okay. This is what one small atom I have taken. Now, here I have taken some big atom. Some big atom. Like this big atom I have taken. Okay. Now, students, here you see. Here, this small atom is cation. Okay, let me imagine that this is what? A cation. Cation means what? Which has a positive charge. So, I have taken small, okay, cation I have taken. I have taken one small cation. Okay, so I have taken one small cation, right? And I have taken one big anion. I have taken one big anion. So, two I have taken, right? So now, so this is a small cation. Cation means what? In which more amount of positive charge is there. So this is a small cation. I have taken some. Okay, this is cation means what? Positive charge is it? Positive charge. Okay, and now here I have taken one big anion. So this anion is little big. Okay, and it has a negative charge. What it has? A negative charge. Clear? So this is anion with a negative charge. Now think these both are spherical in shape. Both are in spherical in shape. Right. Now here what happens, students? Here, this is a cation with a small charge and a positive charge. Okay, cation is positive charge and it is smaller. And it is smaller means what? Here it is very close to the nucleus. Yes, it is very close to the nucleus. Right? It's very close to the nucleus. Right? Now here this is anion which is far from the nucleus. It's what? Far from the nucleus. So here the force of attraction towards the nucleus will be more because it has positive charge and size is less. So the force of attraction of the nucleus will be more. Here the force of attraction will be less. Clear? So now due to this what happens? Due to this force of attraction is more, then what happens? It will try to pull the electron of this one because it's positively charged. So it will try to pull this electron, right? So here this electron also will be attracted toward this nucleus. So now what happens? The shape of this one, okay, it is spherical in shape I said, but the shape of this one, what happens? It is attracted to this one. Okay, it's attracted to this one. So the shape becomes like this. Okay, instead of spherical, so it is attracted towards this one. So like this it becomes, for example, you think it becomes like this. Did you understand? So it becomes like this. So meaning is what? The shape is changed. What happens here? The shape is changed. Okay, so the changing of shape is called a distortion. Okay, so distorting of ion is taking place. Okay, so this phenomena is called polarization. What is called polarization? Is this clear to you? So here, student, here this positive charge is attracting and making the anion to change its shape. Okay, so then this is called polarizing power. What it is called? Polarizing power. It's called polarizing power. Okay, which one? This cation. Cation has a force of attraction. So due to this attraction, it's changing the shape of the anion, right? So this is called the polarizing power or polarization, right? Now here, this is the power of cation. Okay, now due to this, what happens? Anion is changing its shape. Okay, so this is called the polarizability. What is called polarizability? Okay, how much it's getting its shape changed due to the cation is called as a polarizability, right? So now what happens when this shape is changing? As the shape is changing, its covalent nature will be increases. What happens? Its covalent nature will be increases. Okay, so as the covalent nature increases, what happens? The ionic nature will be decreases. What happens? Ionic nature will be decreases. Okay, so this is about the Fazan's rule. So Fazan's rule, what it states is simply no compound is completely 100% ionic or completely 100% covalent. Covalent compound has some amount of ionic properties, among ionic nature, and ionic compounds have the covalent nature. Okay, so that is about the Fazan's rule, right? And this Fazan's rule, what it explains is here how much the polarizing power of this one increases. Okay, how much the polarizing power increases, then the covalent nature in the ionic compound also increases. Covalent nature in the ionic compound also increases. So polarization, okay, so polarization is directly proportional to the polarization is directly proportional to the covalent nature in ionic compounds. Meaning is what? As the polarizing power increases in the ionic compounds, covalent nature is increasing. Is directly proportional to covalent nature. Is this clear? So that is about the Fazan's rule. So very simple, the Fazan's rule. Clear, no? Right. Now, what are the factors which affect the Fazan's rule? These are similar to the what we discussed in the ionic bond, the same thing. Okay. So here the first one, that is charge on the cation. Charge on the cation. Just to explain to you, that is charge and on the cation. Second one, size of the cation. Size of the cation. Okay, size of the cation. And third one, charge on the anion. This also we check now. Charge on the anion. How it will? Okay, I'll explain you. Next, fourth one, electronic configuration on the cation. Electronic configuration on the cation of the cation. Okay. And next, these are the main factors on which the polarization depends. So here you see first charge on the cation. As the charge on the cation increases, cation means what? Positive charge. Cation means what? Positive charge. As the charge on the cation increases, means what? As the positive charge increases, naturally the force of attraction over the electron also increases. Yes or no? The force of attraction over the electron also increases because like charges repel and like charges attracts. So as the positive charge on the cation increases, the force on the of attraction over the electron increases. The meaning is what? It's attracting with more force the electrons, right? So then what happens is the dissortation of the, means the deformation of the anion will be increases. Deformation of the anion will be increases. As the dissortation increases, then covalent nature also increases. Clear now? So I'll explain you. So for example, you see just how I told you that this is a smaller cation, this is a anion, right? So now it has less charge, you think. It has less charge on the cation, okay? Just 1 unit of positive charge, let imagine, okay, 1 unit of positive charge. So what happens? It attracts the electron. So electron will be like this. So see here, the shape becomes like this. If the charge is more on this one, this cation, if the charge is more, means charge is increased. Means what? It puts more electrons. So now the same shape, what happens now? This is the okay shape. So it becomes like this. So more distorted. Okay, but still the charge is more. Okay, it will be distorted more. So as the charge on the cation increases, okay, as the charge on the cation increases, the dissortation of the anion will be increases. Okay, as the dissortation increases, then what happens? The covalent nature increases. The covalent nature increases. Clear now? So this is the first property. As the charge on the cation increases, the covalent nature in ionic compounds increases. Is this clear? So that is about the okay, polarization capacity. Okay, now for example, if I take 3 elements like sodium, magnesium, aluminium. Okay, so I'm taking 3 elements, right? I'm taking 3 elements. Okay, what I do is I'll change the color so you can understand. So here I'm taking the 3 elements, right? Sodium, Na, magnesium, Mg, aluminium, Al. Now, Na is a sodium with atomic number 281. Okay, it attains the stability by losing 1 electron. 281, so it attains the stability by losing 1 electron. When it loses 1 electron, it becomes plus 1. It becomes what? Plus 1. Now come to the magnesium, atomic number is 12. So to its electronic configuration 282. To attain the stability, it has to lose 2 electrons. So it becomes 2, when it loses 2 electrons, it becomes plus 2. Right? Now take the aluminium. Aluminium atomic number is 13. So 283. So to attain the stability, it has to lose 3 electrons. So now plus 3. Clear? So here sodium, magnesium, aluminium. Okay, so 3 are there. But sodium has 1 unit of positive charge, magnesium has 2 units of positive charge, and aluminium has 3 units of positive charge. Okay, so now which can dissort or which can deform the anion more? Naturally aluminium, because aluminium has more positive charge, so it will more pull the electrons, right? So then more it will be distorted. As the distortation increases, covalent nature increases. So the covalent nature of aluminium is greater than the magnesium. When you compare the sodium and magnesium, either magnesium has a plus 2, it has only plus 1. So this one. So therefore, the covalent nature of the aluminium ion is greater than the magnesium, is greater than the sodium. Okay, in similarly in the examination they may ask you like, okay, in which the covalent nature is more, like they'll give 3 compounds like this, okay, NaCl, can you see here, NaCl, okay, and MgCl2, okay, and aluminium AlCl3. In this, all these are chlorines only, but here you see sodium, magnesium and aluminium, right? So here aluminium plus 3, okay, has more positive charge. So here it is more covalent than the magnesium chloride than the sodium chloride. Okay, so this is about the first factor. Clear? Okay, so that's the first factor. Now let's come to the second one, size of the cation. See, this already we discussed. Cation means what? Positive charge. Size of the positive charge ion means cation. If it is small, that is very close to the nucleus. Yes or no? So see here now, for example, I'll draw here. For example, you take what do you take? Lithium, sodium. Okay, okay, we take the lithium. So lithium atomic number is what? 2, 1. So it loses 1 electron. It becomes only 2 electrons. So lithium, it has only, okay, this is the nucleus, only one shell will be there or 2 shells will be there. Okay, I'll take the 2 shells. Okay. Next, sodium. Sodium is 281. Okay. So 281 means what? 3 shells. 1, 2, 3. And potassium. Okay. Potassium 19, 2, 8, 8, 1. Right. So nucleus 1, 2, 3, 4. In this, which has more the force of attraction? Lithium has more force of attraction. Okay, it can pull the electrons very easily than the, this is lithium, this is sodium, this is potassium. Why? Because it is very close to the nucleus, so the force of attraction will be more because it is very close. Now to pull the electron, this one, it is little far. Okay, the force of attraction will be less. And here to pull, it's so far, the force of attraction is less. Right? So if the atomic size is small, okay, the cation size is small, then the force of attraction over the electron will be more. Yes or no? So that distorting power is also more. Is this clear to you? So therefore, here what we can say is that as the size of the cation decreases, the covalent nature in the compounds increases. Okay, so the meaning is what? Just now we discussed, no? So what we will give an example like lithium Li plus, okay, has more covalent nature than the sodium Na plus, than the potassium K plus, and so on. Clear to you? So this is about the size of the cation. Okay, now come to the electronic configuration. Electronic configuration, there are two types of electronic configurations, inert gas configuration itself. One is inert gas configuration, second one is pseudo electronic configuration, pseudo inert gas configuration. So inert gas configuration, you know, it have 8 electrons in their outermost shell. For example, take the argon, for example. Okay, for example, take the argon. So argon atomic number is 18. Argon atomic number is 18. Okay, so what we can write? 288. Okay, this is a normal outermost shell has 8 electrons. Okay, in terms of ions, if I take, I'll take the calcium. Okay, calcium atomic number is 2, atomic number is 20, so electronic configuration 2882. But it is unstable because it has 2 electrons, so it loses 2 electrons to attain the stability. When it loses 2 electrons, then it becomes plus 2. So Ca plus 2 configuration is 288 and outermost shell has a 8 electrons. So this is inert gas electronic configuration, right? Now for example, students, I will take zinc. Okay, I will take the zinc. Do you know zinc atomic number? Zinc atomic number is 30. Okay, actual electronic configuration, what can I write is 18, 2. This is the electronic configuration. I write 30, let us see, 10, 28, 20. Okay, 30. This is the electronic configuration of zinc. But here what happening? For example, it is not stable. So it losing these 2 electrons. When it loses 2 electrons, it becomes Zn plus 2. So Zn plus 2, 8, 18. So the outermost shell, how many electrons are there? 8 electrons are there. So this is called a pseudo electronic configuration. What is called a pseudo electronic configuration. So the elements with the pseudo electronic configuration are more covalent than the inert gas configuration. Now, for example, if you take the calcium and the zinc, which has more covalent nature means what? Zinc has more covalent nature than the calcium. Okay, zinc has more covalent nature than the calcium. Okay, so that is about the polarization, right? So these are the main important factors which can affect the, which can explain the covalent nature in ionic compounds or ionic nature in the covalent compounds. Okay, which was explained by the Fazens. So this is about the Fazens rule, student. Okay, so now what are the applications? Means uses of the Fazens rule. So Fazion's rules are useful in predicting the ionic and covalent nature in the compound. Okay, so we can predict what is the nature of the compound. Okay, so how much covalent nature is there, how much ionic nature is there, based on what? Based on the small size of cation, large size of anion. Okay, opposite. If the size of the cation is smaller, then it should be opposite. Okay, because this is positive charge, anion is negative charge. So bigger charge. Okay, size of the anion and so on. So we can. The main Fazion's rule concept is that if two compounds are given, if they ask you which is more ionic or which is more covalent, so we can say, we can predict okay, which is more covalent and which is more ionic. So that is the most important what do you say, application of the Fazion's rule, right? So that is about the this one. And then yeah, and some other, okay, what we can explain is, as you know that as the ionic nature increases, the melting and boiling points increases. Okay, so because ionic bond means what? The strong electrostatic force of attraction is present between the cation and anion, and electrostatic forces are stronger. So to break them, it requires very high energy. So therefore, the melting and boiling points is directly proportional to the ionic bond. Means as the ionic nature increases, melting and boiling points will be increases. Okay, if two compounds are given like sodium chloride and magnesium chloride and aluminum chloride, in which is more it has more melting and boiling point, then you can say easily that sodium chloride has a more melting and boiling point than the magnesium chloride than the aluminum chloride. Why? Because just now we discussed that aluminum plus 3 is more covalent. So covalent nature is more means what? Ionic nature is less. Here ionic nature is more, covalent nature is less, right? So here as the ionic nature increases, melting and boiling point also increases, right? Similarly, thermal stability. Thermal stability means what? Okay, they are stable at even at a high temperature. The same point here we can say that higher the ionic character, more the thermal stability of the salts. Okay, so as the ionic character increases, the thermal stability means what? The resistance to the heat ability also increases. Next, come to the solubility. Third one is solubility. Solubility means what? Dissolving in like water. So here, as the ionic nature increases, the solubility also increases. Okay, and that's all. And then we can see some covalent characters. So covalent characters, by seeing this, just want to know if two compounds are given. So based on the Fazion's rule, we can say that which is more covalent and which is more ionic. Okay, so that's about the uses applications of Fazion's rule, student. Okay, so with this, this synopsis 4 is completed. Now, once you open the page number 32, you have some practice questions out there. So once check the practice questions. Okay, so open the students page number 32. Concept based questions. First question. The difference between the values of electronegativity of combining atom is larger, results in the formation of C student. This is already we discussed. If the electronegativity difference between the two atoms is more, then that is an ionic bond. If the electronegativity difference is less, then that is a covalent bond. Okay, so here it is ionic bond is the right answer. So option is 1. Okay. Then come to the difference between the values of electronegativity of the combining atom is small. Just now I told you know, if the electronegativity difference between the two atoms is large, they are ionic. If the electronegativity values difference between the two atoms is small, then that is covalent. So option is 2. Third one, the difference in the ionization potential of two atoms is more, leads to a ionic bond. That's very easy. Okay. If the difference between the ionization potential is small, that is covalent bond. So the option is 2. Higher value of electron affinity leads to the formation of covalent bond. Okay, the option is 2. This all already we discussed in the previous class only. Lower value ionic bond. So the option is 1. Now this question, see now. Considering the barium chloride, magnesium chloride, calcium chloride, and barium chloride, beryllium chloride, magnesium chloride, calcium chloride, and barium chloride. Um, Predict which of the following statement is true. Covalent character increases as the atomic number of the metal increases. No. As the atomic number of the metal increases, the ionic nature will be increases. So beryllium chloride is the least ionic compound out of the given chlorides. Beryllium chloride. Yeah. So this is correct. Why? Because students, in the second group elements, in the periodic table, if you see the second group elements, okay, so in the periodic table, so we'll have like beryllium, magnesium, calcium, strontium, barium, radium. These are the second group elements. So see, you already discussed. Yes, see here, you see here, this one are the first group elements. Like what you have seen the first group elements, lithium. Okay, so first group elements what? Lithium, sodium, potassium, rubidium, cesium, francium. So here what we have seen here, so as the atomic size of the cation increases, okay, so which of the least ionic chlorides? So the option is beryllium chloride has because it's the first element, right? So this is just, you can compare with this one. Okay, you can compare with this one. Okay. Now, eighth question, you see the eighth question. Which of the following has the lowest melting point? Calcium fluoride, calcium chloride, calcium bromide and calcium iodide. Okay. So this is calcium iodide. So because calcium is common here, but left side you see, right side you see fluorine, chlorine, bromine, iodine. So as you are moving from top to bottom, atomic size is increasing. Okay. So here the force of attraction is less. So the answer is calcium iodide. 4 is the right option. And ninth one, among the given chloride, lithium, sodium, potassium chloride, which will be extracted from ether or non-covalent solvent. Among the given chlorides, lithium chloride, sodium chloride, potassium chloride, which will be extracted from ether or non-aqueous. So generally non-aqueous, that is lithium chloride, because that's the first element of the, see, chloride is common again, lithium, sodium, potassium, beryllium, lithium, sodium, potassium, rubidium, cesium, francium. So as a first element, so we can say that lithium chloride is the right answer. Okay. So that's about the concept based questions. And shall we discuss the GI mains level 1 also? Okay. So according to the fossils, when the covalent character of the compound is more, then the small cation, larger anion, small size of the cation, small cation and a larger anion. So the option is 1. According to Fossil's rule, when the covalent character of a compound is less, opposite you write. So that is a large cation and a small anion, where it is fourth option. So right, that is fourth option is the right answer. Third, which of the following factor generally favors electrovalence? See, here also same large cation and small anion. So third option, covalent nature of the compound increases with decrease in cation size. Covalent nature increases with the decrease in cation size. So the option is 1, fourth one. Next, the compound having least covalent nature already we discussed, aluminum chloride, magnesium chloride, aluminum already this discussed. So aluminum chloride is the right answer. So the option is 1. Least covalent nature. No. Least covalent nature is potassium chloride. Least covalent is potassium chloride. So potassium chloride is the least covalent nature. Because here there is a more covalent nature. As you are moving down, the covalent nature is increasing. So more covalent nature is aluminum chloride. Least they are asking. So that is potassium chloride. And according to Fossil's rule, ionic character is directly proportional to. Ionic character is directly proportional to size of the cation, right? Size of the inversely proportional size of the anion, charge on the cation. So students, here all of this is the right answer. So 6 is the all, 4 is the right answer. Which of the following compound is more ionic? Just now we discussed that is Sodium, potassium, rubidium, cesium. Cesium chloride. Okay, cesium chloride is more ionic. Okay, and then come to the eighth one. What is the eighth one? Okay, so that's all, students. So with this we stop today. So remaining questions, you practice, read the first the synopsis perfectly, try to understand the Fawson So Fawson you can understand very easily when you read the factors affecting the ionic bond. If you read that perfectly, then Fawson will be very easy to you. Okay, students. So with this we stop. Until next class, take care. Bye.